So, hello everyone. How are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are gonna be working on an infinite series. And yeah, I think I should have written that thing over here, but yeah, let me just write that down. So basically, what we're gonna do, or on which thing we're gonna work on, is this sum as k goes from 1 to infinity of Riemann zeta of 2k plus 1 over 2k plus 1 times x to the 2k plus 1. So this is the thing that we are gonna work on in today's video. Basically, maybe some of you would ask, Aman, what about the even arguments? You haven't bring any kind of thing like that. So, for your kind information, guys, I have made a video in which I have just proved an infinite series actually of natural logarithm of 1 plus natural logarithm of gamma of 1 plus x, right? So in that video I have proved like this sum. I have proved this sum, the even argument of this actually, that is the sum as k goes from 1 to infinity of Riemann zeta of 2k, right, over 2k and times x to the 2k. So we have talked about this, and I think it just came out to be some sort of I'm not quite sure about that, but yeah, I think you gotta be check that out. Or let me just check that out once. I think it was 1 over 2 natural logarithm of pi x, sine of pi x, and I think it was plus 1 over 2 natural logarithm of 1 minus x squared. So yeah, this was the result actually, right, for this infinite sum, and I have proved that in my previous video. But for now, let's just talk about this one. Although it cannot be like generalized, or maybe it cannot be generalized into this some sort of form, but yeah, this can be represented into some sort of infinite sum, right? And that's what we're gonna do in this video. And basically, let me just remind you a little bit about the last video. In my last video actually, in which we did prove that our motive was this thing to be proven, and this was natural logarithm of gamma of 1 plus x equals 1 over 2 times natural logarithm of pi x over sine pi x, and minus 1 over 2 natural logarithm of 1 plus x over 1 minus x, and minus minus Euler-Mastroianni minus 1 times x, and minus this infinite sum as k goes from 1 to infinity of Riemann zeta of 2k plus 1 over 2k plus 1 times x to the 2k plus 1. So this was the thing on which we have done work, and actually we had proven that in our last video, right? And I took 35 minutes to prove this down. So you can consider watching that. And in that video, I have proved the like this sum with the like even arguments. And guess what? From this equation, we can say we are here with the thing that we are here for actually, and this is the sum as isolating this infinite sum actually. So that's going to be giving us. Wait a second. So basically, it's gonna be giving us natural logarithm of gamma of 1 plus x and minus 1 over 2 times natural logarithm of pi x over sine pi x, and plus 1 over 2 times natural logarithm of 1 plus x over 1 minus x, and plus I think it's positive over there. So we have to just take the negative of all these terms. And it's negative. So here is your result. And guess what? This is the sum that we are here for actually. And here's the result, because from this very equation, the one which we have proved, we can isolate all the things, but isolate this sum, and yeah, it's equal. This is the result actually. So that the sum is being equals, like this is the result, that is negative natural logarithm of gamma of 1 plus x, and then you are having plus 1 over 2 natural logarithm of pi x over sine pi x, and minus 1 over 2 natural logarithm of 1 plus x over 1 minus x, and then you are minus Euler masculine minus 1 times x. So here's the result, guys. So now you would ask me, what else you're gonna do? Because you said that this video is for this sum, and here you are having the result of this sum from this equation that you have proved in the last video. So what's wrong? Everything is fine, right? But guess what? This is not the result that we are gonna find here, because this can be done by your own, right? You can just, if I'm just gonna ask you, just find this sum. So what you're gonna do, that isolate this sum, and you would get the answer the way we just did it now. But this is not the end of this video, because we ain't gonna find this sum with the help of this only equation. We're gonna introduce something different and another equation there. So yeah, that's fine. That sounds amazing. And the other equation is, even I have proved that one as well. So don't worry that I'm gonna use anything else that I haven't talked about yet. But yeah, we have proved this. So this is the Kummer series, and I have proved this recently, right? And this is natural logarithm of gamma of x equals 1 over 2 minus x and times Euler masculine plus natural logarithm of 2 pi, and then you are having plus 1 over 2 natural logarithm of pi over sine pi x, and then minus 1 over pi times the sum as k goes from 1 to infinity of natural logarithm of k over k and sine of 2 pi kx. So this is your Kummer series. I think I have noted everything down perfectly. Let me just check that once. I think, no, it's not minus, it's plus there. And yeah. Okay. So what we're gonna do with this here? Basically, we are having natural logarithm of gamma of 1 plus x here, and we can replace x with 1 plus x both sides in order to get natural logarithm of gamma of 1 plus x on the left hand side, and then we're gonna equate the right hand side of this equation with the right hand side of this equation that we would be getting after replacing x with 1 plus x. So that sounds kind of amazing, but at the same time disgusting. Okay, but it's all right, it's subjective, but for me it's amazing. Yeah. Okay, so let's just do this. So yeah, we are having this one. So yeah, let's just talk about the Kummer series when we evaluate that for like after replacing x with 1 plus x. Yeah. So wait a second, guys, and now we are good to go. So replacing x with 1 plus x. So basically our left hand side is gonna be natural logarithm of gamma of 1 plus x equals, that's gonna be giving us 1 over 2 minus 1 plus x, replacing x with 1 plus x, and Euler masculine plus natural logarithm of 2 pi, and plus 1 over 2 natural logarithm of pi over sine pi 1 plus x, right? Yeah. And then 1 over pi times the sum as k goes from 1 to infinity of natural logarithm of k over k sine of 2 pi k 1 plus x. So when we replace x with 1 plus x in that equation, in the fundamental equation of the Kummer series, so we're gonna be having this kind of things. Okay, and now if we talk about the very first term, that is 1 over 2 minus, so it's 1 over 2 minus 1 minus x, so basically it's minus 1 over 2 minus x, right? Okay, so let's just talk about that. And it's natural logarithm of gamma of 1 plus x. And we ain't gonna just multiply this into this parenthesis because that's not gonna change the definition of sine of some sort of multiple of pi. So let's just leave that alone. And so for this one, because again it's just adding 1 to the x, so it's not gonna be like making any kind of disturbance to us. But let's just talk about this one. So it's gonna be negative 1 over 2 minus x, and it's Euler-Mascheroni plus natural logarithm of 2 pi, and then we are having 1 over 2 natural logarithm of pi over sine pi 1 plus x, and plus 1 over pi times the sum as k goes from 1 to infinity of natural logarithm of k over k sine of 2 pi k 1 plus x. So we are having this very equation after replacing x with 1 plus x. And guess what? We were having natural logarithm of gamma of 1 plus x earlier. That was the very first equation, and I'm not quite sure what's the name of that equation, but it's alright. We would be writing, or we would be denoting that equation as for the natural logarithm of gamma of 1 plus x, which was something sort of this: 1 over 2 natural logarithm of pi x over pi x, and then we were having minus 1 over 2 natural logarithm of 1 plus x over 1 minus x minus Euler-Mascheroni minus 1 times x, and then minus the sum as k goes from 1 to infinity of Riemann zeta of 2k plus 1 over 2k plus 1 and x to the 2k plus 1. So let me just check this out once. Okay, yeah, everything is fine. Okay, so we are having two very equations. I'm just gonna highlighting them. The very first equation is this one, and that is representing the natural logarithm of gamma of 1 plus x, and the second one is also representing the same thing. So what we're gonna do here, we are gonna, from this equation, we are having that the expression for this one, and from this equation we are having the expression for that one. So basically this part, the RHS, that means the right hand side of this equation, is equal to the right hand side of this equation. Isn't that, guys? Okay, so I think it's a lot of things to be written down in a single stuff, but yeah, let's just do this. So I'm just gonna equate the right hand side of this equation to the right hand side of this equation. So basically we're having, factoring out a negative, so yeah, it's minus 1 over 2 minus x, well, plus actually, because yeah, and it's Euler-Mascheroni plus natural logarithm of 2 pi, and plus 1 over 2 natural logarithm of pi over sine pi 1 plus x, and plus 1 over pi times the sum as k goes from 1 to infinity of natural logarithm of k over k. I think I'm not having space there, so I don't need to write that down. But yeah, I think let me just write down the right hand side of this equation actually, and then we will be just writing it equal to this one on this board actually. So we are having sine of 2 pi k 1 plus x, right? So yeah. Okay, so yeah, we are having minus 1 over 2 plus x times Euler Mascheroni plus natural logarithm of 2 pi, okay, and plus 1 over 2 natural logarithm of pi over sine pi 1 plus x, and plus 1 over pi times the sum as k goes from 1 to infinity of natural logarithm of k over k, and it's sine 2 pi k 1 plus x, and that is being equals to this right hand side of this one. So it's 1 over 2 natural logarithm of pi x over sine pi x, right? And then we are having minus 1 over 2, and it's natural logarithm of 1 plus x over 1 minus x, and minus Euler Mascheroni minus 1 times x, and minus this sum, which we are here for the Riemann zeta of 2k plus 1 over 2k plus 1 and x to the 2k plus 1. So yeah, this is what it looks like, and that's pretty disgusting because we are having a lot of things nested. Whoa. Okay, yeah, we ain't having anything other option without dealing with these all things, so let's just deal with them. So what I'm gonna do here next is, obviously I have to erase that one because it's not gonna be ended up in this very space. So I have to erase this one, and then we will be talking about that. Okay, so what I'm gonna do here is, we can just multiply both sides with a negative sign in order to get a positive here, and then we'll just like add and subtract the terms with respect to each other on the right hand side and left hand side in order to just isolate this one, right? So basically I'm just going to change the signs of all the terms. So it's going to be positive and it's going to be negative. I hope you guys are clear with that. And it's going to be negative, and here you're going to be a negative in front, and here you're going to be positive, positive, and it's positive. Okay, and now just adding 1 over 2 times natural logarithm of 1 plus x over 1 minus x. I'm so sorry. Subtracting both sides with this term, and adding both sides with this term, right? So we would be just getting rid of all these three terms, and we would be isolating this infinite sum. So how does it gonna looks like? It's here. The sum as k goes from 1 to infinity of Riemann zeta of 2k plus 1 over 2k plus 1, and it's x to the 2k plus 1. So we are having 1 over 2 plus it's x, and times like Euler Mascheroni plus natural logarithm of 2 pi, okay, and then minus 1 over 2 natural logarithm of pi over sine pi 1 plus x, right? And then minus the sum, minus 1 over pi, the sum as k goes from 1 to infinity of natural logarithm of k over k, and it's sine of 2 pi k 1 plus x. And then this we are adding this term, right? So it's 1 over 2 natural logarithm of pi x over sine pi x, and subtracting this big chunk of thing. So we are having minus 1 over 2 natural logarithm of 1 plus x over 1 minus x, and minus, actually Euler masculine minus 1 times x. So here you are with the closest, I would say, I'm sorry, mine, actually it's mine, like I have searched out for the closest form, so it just like where I just got searched there, so that was showing some sort of, they won the easiest equation that I have proved, that was something sort of this, I'm not quite sure, but yeah, I have proved that as well, in which we were having the Riemann zeta of n over n, and it's actually n, something sort of that, but I just went for this one, and yeah, it's kind of amazing. But we have to solve some natural logarithms, because we are having some like terms, that means this one, and then some, let's just expand them a little bit, and then let's just see what we are having. So yeah, let's just take a look at this. So I'm just gonna expand the stuffs, right? But yeah, so basically I'm just gonna talk about the right hand side. So we are having, I'm just gonna multiplying this parenthesis with this one. So we're gonna be having 1 over 2 times Euler Mascheroni, and plus 1 over 2 natural logarithm of 2 pi, and Euler Mascheroni times x, and plus x times natural logarithm of 2 pi. Okay, and we can write this as minus 1 over 2 natural logarithm of pi, and plus 1 over 2 natural logarithm of sine of pi plus pi x. Well, let's just multiply that pi into that parenthesis, a small parenthesis actually. So yeah, and then we are having that sum. But before that, let's talk about this this short terms, actually this beautiful terms. So this can be written as 1 over 2 times natural logarithm of pi plus 1 over 2 times natural logarithm of x, and minus 1 over 2 times natural logarithm of sine pi x, right? And well, we ain't gonna bother this one, because we are not having any sort of like terms which are matching to that, in order to give us something different. But let's just talk about the last term, that is minus Euler Mascheroni times x, and plus x, and minus 1 over 2 times natural logarithm of 1 plus x over 1 minus x. And we are having this sum, right? We know that. And this one on the left hand side. Let's check some sort of good cancellations. I think I just got something. This 1 over 2 times natural logarithm of pi, and this minus 1 over 2 times natural logarithm of pi getting cancels out. And Euler Mascheroni times x minus Euler Mascheroni times x, we just got rid of that as well. And we are, yeah, it's just amazing. Okay, so I'm just going to combine this term. So that's going to be 1 over 2 times Euler Mascheroni plus natural logarithm of 2 pi, and then x plus this. So x plus x times natural logarithm of 2 pi, right? And then we are having minus 1 over 2 times natural logarithm of 1 plus x over 1 minus x, right? Hey, wait, oh, I'm sorry. I should have written this one as well into this parenthesis actually. So let me just erase this a little bit. And we are having 1 over 2 times natural logarithm of x plus x natural logarithm of 2 pi, and plus x. So I'll just combine this one, and this one, right? And then this minus 1 over 2 natural logarithm of 1 plus x over 1 minus x. And then we are combining this natural logarithm of sine of pi plus pi x and this one. So yeah, we can write this as 1 over 2 natural logarithm of sine pi plus pi x over sine pi x. I hope you guys are clear with that. Okay, so basically after solving this right hand side without this infinite sum, because we ain't gonna bother that. We are having this much amount of thing, that is this one. Okay, and still we can solve this one, and let me just solve that, solve this one a little bit. We know that sine pi x plus pi is sine pi x cosine of pi plus cosine pi x sine of pi. And we know that we are not sure about x, right? So sine of pi is 0, so it's 0, and we are having sine of pi x, so over sine of pi x. So we just sorted out the sine of pi x and pi x as well. And finally, if we divide this with this one, so we are having cosine of pi x. Oh, I'm sorry. Oh my goodness, my chalk has broken. I should have. Yeah, so basically we are having cosine of pi here. And cosine of pi, we well know about that. Cosine, well, we have a formula that says cosine of n pi is minus 1 to the n. So when n is 1, it's just negative 1. So finally, we are having this thing to be sorted out to negative 1. Like that's pretty amazing, guys. And look, this can be written as 1 over 2 natural logarithm of minus 1, and natural logarithm of minus 1 is I pi, so it's I pi over 2. And how did I say that natural logarithm of minus 1 is I pi? From this equation, e to the I pi is minus 1. So taking natural logarithm both sides, that's going to be I pi equals natural logarithm of negative 1. So we have got some sort of complex numbers inside this because we are having a complex unit. Okay, so yeah, okay, and let's just write all these terms with the places of this one, and this would be just left as it is. So yeah, I'm not gonna erase the sum which we are here for, but the rest of the things would be erased. And it's been 27 minutes. Oh my goodness, that's quite a long video. It's been okay. So writing these terms, actually the one which we have solved, yeah, so basically we are having 1 over 2 times Euler-Mascheroni plus natural logarithm of 2 pi. And if we talk about this, so we can factor 1 over 2, and it's natural logarithm of x plus 2x natural logarithm of 2 pi and plus 2x, right? And then minus 1 over 2 natural logarithm of 1 plus x over 1 minus x, right? And this one like we did evaluated it to I pi over 2, so it's plus I pi over 2. And I think this is the closest form that I have evaluated so far, because I cannot solve this further anymore. Or maybe we can do something. Oh, I'm sorry, I did forget the sum. It's yeah, I think it was minus of that. Yeah, it was minus 1 over pi times this sum, and yeah, as k goes from 1 to infinity of natural logarithm of k over k, and it's sine of 2 pi k 1 plus x. So guys, I think it's done, and this is the closest form that I have found by myself. And yeah, so yeah, actually we just did something sort of this. So basically from this video we can say that the infinite sum of the odd arguments of Riemann zeta over that argument, like this one, and times x to the that argument as well, equals 1 over 2 times Euler-Mascheroni plus natural logarithm of 2 pi and plus 1 over 2 times natural logarithm of x plus 2x times natural logarithm of 2 pi and plus 2x, right? And minus 1 over 2 times natural logarithm of 1 plus x over 1 minus x and plus I pi over 2. That was quite amazing the way we just got this. And minus 1 over pi times the sum as k goes from 1 to infinity of natural logarithm of k over k times sine of 2 pi k and times 1 plus x. So yeah, that was pretty amazing. That was fantastic. And hey, wait. Yeah, actually I did a mistake over here. And you know what that mistake is? Let me just tell you about that. But before that, let me just check whether everything I have written is correct. And I think it's not minus 1 over pi. Guys, just let me just check this once. Check this out once actually. Because we have isolated that. Yeah, it's perfectly fine. You know what? Like, I have written this sine of pi plus pi x as just sine of pi x, and I just cancelled out these terms because it's plus 1. Like I have just got a wrong answer there. Let me just show you. So this is the work that I have done, and take a look at this. Yeah, so here, so I have considered this. I should have look, wait, yeah, here. So I should have wait a second. Yeah, I have replaced x with 1 plus x here, right, in Kummer series. So I have written there, but I just forgot that to copy that down again in this page, and I just forgot that here, right? So that's why I just got the wrong answer. I didn't got this one because I just got rid of these two terms. That's why I didn't put this. But yeah, this is the actual thing, right? And everything just went exactly and clearly, right? So yeah, guys, again, guys, if you got to learn something out of it, please make sure to like, subscribe, and share. And if you haven't got out so far, you are free to ask me in the comment section. I'll be there to reply your questions. And maybe you found something sort of better way to just generalize this, you can say. And if you have some sort of that, so please share it with me. I'm just here to listen some new ideas. Stay here about your thoughts. So yeah, goodbye guys, take care, love you, and enjoy your life, and enjoy learning mathematics if you are a mathematics lover, right? Goodbye guys, love you, take care, and love yourself, because you are the first guy. I'm just waiting this video to be 33 minutes, and here it is.